Okay. Now, the first thing we should know is what exactly is a capacitor. Capacitor is a solid state electronic device that stores energy by redistributing charge. The symbol for capacitor is two parallel plates and wires going out like this. Okay. In reality, capacitor basically looks like it's a cylinder shape. It's two wires going out like this. Is it clear, everybody? However, the definition they're going to ask is the one for the capacitance. So, capacitance is defined as the ratio of charge on one of the plates to the potential difference across the plates. Is it clear, everybody? Okay, let it sink. Right. Okay, here. What it means is basically the symbol that we're going to use is capital C, and the formula for this is that C is equal to the charge on one of the plates divided by the potential difference across it. Now remember, capacitance is a scalar quantity, so it does not really matter if it has a direction or not. The SI units for capacitance is charge per volt or simply farads. It's capital F, right? So generally, few things will come in paper 5, few things will not, so we have to cover everything. So basically, when you put a capacitor, it is two parallel plates, and then of course it is connected to a sort of a circuit. Wait a second, please. Yep, and here as well. So this is the positive side of the supply, this is the negative side. So what really happens here is that between these plates we have to place sort of a material, write this. So this material is the dielectric, which is basically an insulator in between. I'll tell you why. So this is for paper 5 that you need to know how to draw this. And also we would like to make a switch. Okay. Now, so when the switch is basically open, like you see right now, remember writing a note here that there are equal number of positive and negative charges on each plate. And the reason for placing a dielectric is to prevent charges jumping to the other plate directly. That's why we do not want induction to take place. Okay. Now, let's look at this when the capacitor, when the switch is closed. Now, when the switch is closed, so the first thing is that we should know that how a capacitor is charged. Okay. So the moment you close the switch, now the electrons basically, let's call this for reference, I'm just saying, let's call this plate X and this plate Y, and then also put a voltmeter across it so that we can also see what is happening to the voltage across these plates. Okay. Now the moment switch is closed, the electrons which are being attracted by the positive supply because of the potential difference, right? They start to move in this direction. As the electrons move, they leave the positive charges on this side, and because now there is a potential, the other plate Y feels that okay, it has less, it needs to attract the positive, so it borrows the same number of electrons towards the Y plate. So the electrons start to gather here. Is it clear, everyone? So here we get a voltage V and the supply voltage was V naught. So this way what we're really doing is we are actually redistributing, we're picking electrons from one plate X and then we're redistributing the same number of electrons to the other plate Y. Alright, Rafe, Aman, Gatika, Saman, is it clear?
Yes, sir.
So we can write this down as well. We can say that when the switch is closed, potential difference is experienced due to which electrons move to positive terminal and then the battery or supply from negative terminal provides electrons to the other plate. Now,
So at the end, we get one positively charged plate and one negatively charged plate.
yes, exactly. This is what we want to do, right? So basically, as the negative charges are displaced from X they are redistributed by the battery or supply to the other plate. Why? Is it clear, everybody? Now, as more and more charges are redistributed, the potential difference across the battery and the plates becomes the same. So what I mean by this is, initially both are like both the plates have no potential difference because equal number of charges are there. But let's suppose if it had 5 volts, so the voltage across this will keep on increasing as the redistribution occurs. The moment it also becomes 5 volts because now it's redistributed, right? So it becomes the same. Then what happens is that then the charges stop flowing, hence charging terminates. All right. The work done by the battery is stored in the capacitor as it gets charged. Is it clear, everybody? So what you need to understand is that the battery and the plates have a potential difference initially, and as there is potential difference, so the charges will try to move from X to Y just to make sure the potential becomes the same. And at one point, when there are enough charges on X and Y, the potential difference between the battery and the plates become the same, so the charging basically terminates. And in that process, the work done by the battery is basically stored as energy in those plates that we can use later. Do you guys understand this? If you have any
So
questions,
can you
please.
repeat the last one?
Yeah, what I'm saying is, so initially, the plates were not charged at all, right? If the plates are not charged, like they're here, and the battery is the battery, of course. So it has a potential, let's suppose 5 volts, and here the potential is 0 volts. Okay? There's a difference between them, right?
Yes, sir.
So what will happen? The charges are gonna flow. They're gonna flow, and then they're going to gather. So when the redistribution is occurring, so what is really happening? This potential is increasing. So it's like increasing 1 volt, 2 volt, 3 volt, and then when it comes to 5 volts, now the potential difference between the plate and the battery is just the same, right? Because the potential difference is not there anymore, so the charging will terminate. Do you understand?
Yes, sir.
And during this process, how are these charges moving? They're moving because the battery is doing work on them, so that it is supplying energy, right?
Right.
And where is that energy going? It is basically being stored within the plates of the capacitor so that we can use it later. Do you understand? So,
Yes, sir. Got.
the point of all this is that we are taking out some chunk of energy from the battery and then we're putting this energy into the plates of the capacitor by charging those plates. Understood? So, the idea, the logic is that it's not about, suppose there were like like there were 10 charges before, so each plate will still have 10 and 10 charges, but this time only redistribution has occurred. Do you guys understand what I'm saying? So, if they ask you what is basically being stored in the capacitor, you always say the energy is being stored because the charges are just moved from one plate to another. There is nothing really changed with respect to charge. The same number of charges on one plate and another. It's just that we have redistributed and put energy into it. Understood?
Yes, sir.
So, okay, you guys can write it down. This is very important because they're going to ask you this, and you should always have this concept in mind. Okay. Right. Now, let's go forward. So now that we have learned how to charge this, we also need to know how the graphs are formed, right? So we're going to basically learn about charging graphs of a capacitor. Now, so generally, what we do is capacitors are placed in sort of way. Okay, please don't draw this unless I have completed the whole drawing so that you guys can understand what I basically want. Don't have to raise it. Okay, so there is a battery, that's V naught. There's a capacitance of capacitor capacitance C, and we have also a voltmeter across it, just to know that it's charged or not. And then we have a resistor that is connected in parallel to this. Now, generally, when you're charging a capacitor, you would want the capacitor, it's a two-way switch, so your switch is placed at A, right, like this. So when it is in this state, basically the battery is going to charge the capacitor. Okay, this is basically called the charging configuration, I believe. Okay, now anyway, so first of all, we are going to draw the graph of voltage. Now, for voltage, when it's charging, you guys need to understand that we're looking at the voltage across the capacitor, which is V right here. So we're going to write V and V, and we're going to write time in seconds. So as the charging continues, the voltage increases till it becomes constant at one point. So this is basically the same. It reaches the same value as V naught, as the battery's voltage, because we just learned that the charging terminates when the potential difference between the battery and the capacitor is the same. I mean, it's zero. Is it clear, everybody? Now the question most of the people have, that why is it a curved line? Like, why is it like that? Why charging is faster at start and slower at end? Why is it like a decreasing gradient curve? So what you guys need to understand is that this is basically because the potential difference between capacitor and battery keeps getting less, because you're approaching the same potential as a battery. Hence, the other reason is that a great repulsive force on the plate for incoming charges develop. Because you see, what we're basically doing is, on the plate, on one side, if they're all positive, one side all are negative, like most of them. So what you need to understand is that as more and more electrons are going to come in, electrons and electrons repel each other. We've done it in electric fields. So the more the electrons gather, which means the force of repulsion for the new incoming electrons will also be greater. Is it clear? And the last thing is, because less and less space is left for more charges, as the charge density, which means the number of charges per unit volume, increases. Any questions? Please let me know. In 10 minutes, I think now in like 8 minutes, you guys need to rejoin. Okay. Now. All right. Is it clear, everybody? Now, the next graph that we want to look at is the charge graph. So what you're going to do is make the same graph. So you're looking at charge on one of the plates. We always do that. So charge in Q, time, so charge in coulombs, time in seconds. So for this one, the graph basically is identical to the voltage one. So it reaches a maximum charge. So basically it depends on the capacity. So when the capacity fills up, like I've said, that the space becomes less and less. So as the number of charges increases, so at one point, when the current really stops, no more charges will be there. And the reason current stop is because the potential difference will be no more. And then there will be so much repulsion that no other charge can enter then. So it capacity is getting full. So when it is full, the maximum number of charges are there. Is it clear, everybody? The last graph of charging is basically,
So doesn't the charge on one of the plate decrease?
no, it never decreases. It sound like that, you know. So if negative charges are decreasing on one plate, the positive is increasing on that plate. Do you understand? So net charge remains the same. Understood?
Okay, yeah.
Yeah. So current graph is the one that is opposite of these two, because initially there is a lot of potential difference, which is good for current to flow. And then as the potential difference decreases and repulsion increases, the current is going to reduce to just zero at the end. Is it clear, everybody? So basically, the charge and the voltage graph is the same, but the current graph is the opposite, because initially there will be like a large current flowing and then slowly it is going to decrease to zero, because the reason is that eventually we are reaching a point where there won't be any flow of charge, and when there is no flow of charge, current is basically flow of charge per unit time, so it will become zero. Any questions? Okay. That's pretty good. Okay. So then let's talk about, once we have charged this, right? What would you do then? Okay. So naturally you have, charged it, and now it has basically charges that are gathered onto it. This way we have fully charged stored energy, and now we would like to discharge it. So discharging of a capacitor. So for discharging, I'm going to copy this diagram. You guys should remake this if you're not working digitally, unfortunately. And let me show you how the configuration just changes into the same shape. Put it right here. So now what you guys are going to do is you're going to place the switch to the other end, which is B, like this. And now the battery is disconnected, but you see now the capacitor is directly connected to the resistor. And because the capacitor is at full voltage and resistor has none, so now the capacitor is going to provide the stored energy to the load resistor that we put in. How? Because there is a potential difference, so the charges will now flow like this through the resistor and try to balance out on the other plate. Do you guys understand? During that movement that you see, they're going to supply energy to the resistor, so you can put a bulb, you can put anything that you want to use, a fan maybe, right? So that would let the resistor get some energy as well. Now, what you guys need to do is you guys need to basically draw the discharging curves. So for the first one, we have the voltage curve, then we'll draw the charge curve, and then we're going to draw the current curve. Okay, so for the voltage one, let me just draw all of them in just one go, because now you guys understand what is really happening. So this is voltage versus time, this is charge versus time, and this is current versus time. Now we are looking at the voltmeter, so as the charges will flow, the voltage will decrease. So of course it started from V0, and slowly the voltage is gonna decrease in a very long time. Basically it's going to go like this. Okay, the charge similarly starts from the maximum charge on one of the plates, and then it decreases slowly. And same goes for the current, because initially the potential difference so much, you have the largest possible current, and then it decreases slowly like this. Is it clear, everybody? So what you guys need to remember is that all of these curves that I've drawn, in discharging they behave the same way, because as the voltage is reducing, the charge is reducing on one of the plates, and the current is also reducing. Is it clear? Okay. Now remember, these curves that I have shown, okay, so basically remember that these curves that I have shown basically go through an exponential decay. And these are exponential curves, right? Now exponential decay, they have a certain equation that we need to remember. Okay, so for an exponential decay, generally the general formula is x equals to x naught e minus t over rc. Okay, this equation is very important and you guys need to remember this. Okay, so for voltage, this equation becomes v equals to v naught e minus t over rc. For, let me put it in a box then, because then you might, you know, and let's put it right. Okay, I want to put it right here so you guys don't get confused. So For voltage, basically this is like this. For charge, the equation becomes Q equals to Q naught E minus T over RC, and for I it is I equals to I naught E minus T over RC. E is the exponent. How do you find exponent in your calculator? It's this key. You see ln right here, and here on top of it you press shift, and when you press shift you will see exponent like this. Okay, so this is a math function. Now remember this, very important. Here V is the voltage at time t, V naught is the maximum voltage, potential difference really, T is the time elapsed, whatever the time has, R is the resistance of the resistor, right? So that's this R right here. And then C is the capacitance of the capacitor. So you guys need to remember all of these are the same. Like Q would be the charge at time t, Q naught is the maximum charge, and rest of the things are same. And then for I is the current at time t, I naught would be the maximum current, that's in the start, and the rest of the things are same. Now let's suppose they give you a curve and they want you to find it. So they say, okay, at time t, like time t, we want to find the current. So you just go to the curve, you check out what is the current I here, and then you can use the value of capacitance and resistance to find that I or anything that's missing in the equation. Is it clear, everybody? Same goes for all others. Like this will be at time t, a certain charge you want to find. For voltage at time t, a certain voltage you want to find. So basically these equations will do it. Now to remember this equation, you just need to remember that basically the real thing is T upon RC. The rest of things, whatever is given, you can just switch it. Is it clear, everybody? Any questions here? Okay. Okay, let me show you a question that relates to it. Wait a second, please. And I just need to teach you non-math people some of the log functions as well. That's not something I got to do. Okay. Now, now let's look at this. So suppose this configuration is given. Now they have just given a curve. So this value that you see right here is basically, this is in millivolts. So this is I naught in millivolts, and this is graph shows a discharging current curve, and the configuration is discharging. The capacitance is 2000 microfarad, and you can pick any point from the graph that you want of time and t. So I picked 0.2 milliampere and this already. Now they say find the value of RC. Okay, so I know this is a current graph, so I would use the equation I equals to I naught E minus T over RC. I want this RC function, right? So what I'm going to do is I'm going to say, okay, I was 0.2 milliamps, and I'm going to divide I naught, which is 1.7 milliamps. I'm left with minus T was basically 0.5 over RC, like that. Is it clear, everybody? Okay. Now what you're going to do is milli and milliamps will cancel out, so don't really matter. You got to take ln. So when you take ln, it's a log function of 0.2 over 1.7, you also got to take ln of e minus 0.5. So it basically on the both side it will happen. I just want to tell you this very, very important fact, and this is like for the math, non-math people, that if there is a function ex and then you take ln ex, so the power basically comes out, so it will become x times ln e. And just to tell you this, that ln e is equal to 1, so you can just write 1. Okay, so for this one I've taken ln e 0.2 1.7 and minus 0.5 over RC will come here, multiplied by just ln e, which I've just told you is equal to 1. So ultimately you get basically when you use the calculator, so you'll see you press ln and then you write 0.2 divided by 1.7, and then the value is about minus 2.14, and this will be minus 0.5 over RC multiplied by just 1. ln e is equal to 1. Okay, so now minus minus will automatically cancel out, so that would mean that RC will be equal to 0.5 divided by 2.14. Oh, okay. Well, isn't it a bit too high? Okay, never mind. So then you just need to do 0.5 divided by 2.14. So the factor of RC will become equal to 0.234. We're going to learn what is RC later, but right now you guys need to know that this is the value and this is how we use these functions. Everybody is clear about it? Any questions? Please let me know. Gatika, you don't take math, right?
No, sir, I don't take maths.
And Aman, you take math?
No, sir.
Okay, and Suman? Okay, I think Suman doesn't take math as well. Alright, so you guys understand what I've done? Will you be able to do it in exam? Do you understand the ln function? Okay. Now in the next part it says find R. Now, so we already know from the previous part that RC is equal to 0.3234 and the capacitance is 2000 microfarads. So what I'm going to do is I'm going to write R times 2000 microfarads equals to 0.234. To convert micro into just farads, because I want SI units, I'll multiply 10 raised to minus 6, micro is 10 raised to minus 6 equals to 0.34. So now you take out your calculator, you divide 0.234 by 2000 times 10 raised to power minus 6. So that basically is about 120 ohms, and that would be the value of the resistor that is put in the circuit. Understood?
Yes, sir.
Okay, that's pretty good. Okay. Okay. So tomorrow, like before the class today, inshallah, I will be sending you um, a sort of log rules. Okay. And in Saturday's class, we can just learn a bit about logs, because if you don't understand logs, you might have trouble doing these questions, because logs are very, very important in this, right? Because they might ask you this. Okay. If you have any questions, please let me know. Otherwise, I think we will end the class right here and continue it tomorrow.